Okay, so we're going to learn how to graph the sine wave. Okay. Hopefully at this point you already know all the different terminology. If you don't, then you're going to have to review your notes or see me. But you're going to have to know amplitude, sinusoidal axis, period, etc. Okay. This is just designed to give you an easy way to graph these. So the way that I always graph these is I work from right to left. Use that information to draw the sine wave. Okay, so I start on the right. It's +1. That means my sinusoidal axis is at 1. So I take and draw a dotted line at 1 all the way across. Okay, next up. Okay, it says theta subtract 90 degrees. That means my sine wave has shifted 90 degrees to the right. Okay, so a horizontal shift of 90 degrees. Okay, so I'm not going to start my sine wave at 0 degrees like the normal one does. Okay, I'm going to start at 90. So I put another dotted line down at 90 degrees to indicate my new starting point. Next. I have a 2 out in front. Okay? It's the number that affects my period. Okay? If you're not sure how it affects your period, whether it doubles it or halves it, okay, think of the reciprocal. I take the normal period, which is 360 degrees, and think reciprocal. Multiply by the reciprocal of 2, which is 1/2. Okay? So my period is going to be 180 degrees. So that's going to give me my second vertical line to put in. I know I started at 90 degrees, and then if the period is 180 degrees, I go up 180 to 270, and that's where I'll get one full period of the sine wave. So the last number I have to deal with, the gain is a 2. That's my amplitude. Okay? So I work with dots. Okay, I know my sine wave starts here on the sinusoidal axis. It ends on the sinusoidal axis, or one full period ends on the sinusoidal axis. In the middle, it passes through the sinusoidal axis. Okay. Now, I draw min and max points. So an amplitude of 2 means halfway in between these dots, I go up 2. In between these ones, I'm going down 2. I just finish it off by drawing the actual sine wave. Like that. And let's quickly do one more example. If you want extra time for any of these things, just hit the pause button, or however you have to do it in your browser. But I'm just going to carry on. Let's change these numbers. All right, let's use instead, again, we'll go with an amplitude of 2. Let's change this to a 1/2. Again, let's go with minus 90 degrees, and let's go with a -1 here. All right. So again, working right to left. Sinusoidal axis is at -1. So I go ahead and put that sinusoidal axis on. There it is. Take care of that. I've shifted 90 degrees to the right. It's -90, 90 degrees to the right. Okay, so I'm starting here. If this had been a +90, I would have been going left 90 degrees from this normal starting point. I would have to go over here to start. But it had -90, it's 90 degrees to the right. Next, the period. normal 360 degrees times the reciprocal. Okay, the reciprocal of 1/2 is 2 over 1, or just 2. Okay, so my new period is 720 degrees. Really long compared to what we just did. Okay, so if I start at 90, and add another 720 degrees, I'm all the way up here at 810. So this is where my next wave ends. This particular sine wave ends. So the only thing I have left to do is include the amplitude. Which again is 2. Okay. So as I said before, I mark the 2 endpoints. Then I mark the middle point. Okay. So the middle here is 450. So I know it passes through there. Okay. Then I use my amplitude, which is 2. So halfway between these 2 dots, I have a maximum going up 2 from the horizontal axis. So 1, 1, 2. So there's the max point. Okay. And then halfway between these 2 dots, right here at 630, I go 2 down from the horizontal axis. 1, 2. And we just draw it. There we are.